Now we're going to continue on with Chapter 4, and we're going to continue covering the connective tissue. Our objective for this section is to compare the structures and functions of the various types of connective tissues. First of all, connective tissue is a protective structural framework for other tissues. There are three basic components: specialized cells, solid extracellular protein fibers, and a fluid extracellular ground substance. The extracellular components of connective tissue make up the matrix. The characteristics of connective tissue are support and protection, transport of materials, storage of energy reserves, and defense of the body. In other words, these are the functions of the connective tissue. This concept map is an excellent description of the connective tissues. It shows the three different types of connective tissues and their examples. So the first type of connective tissue is connective tissue proper. It can be divided into loose connective tissue or dense connective tissue. The second type of connective tissue is fluid connective tissue, and it can be divided into blood and lymph. And the third division or type of connective tissue is the supportive connective tissue, and it can be divided into cartilage and bone. Now, as we go on, there are three types of connective tissue: connective tissue proper, fluid connective tissue, and supportive connective tissue. Here are the major cells of connective tissue proper. Fibroblasts, they're the most abundant cells in connective tissue proper. Macrophages, they're scattered throughout the matrix and they phagocyze damaged cells or pathogens that enter the tissue. Fat cells, or adipocytes, they vary in number and are energy storage cells. Mast cells, they're small mobile cells found near blood vessels. Collagen fibers, they're long, straight, unbranched, they're very strong and flexible, they're the most common. And then elastic fibers are branched and wavy. After stretching, they will return to their original length. Finally, we have reticular fibers. They're made of the same protein subunits as collagen fibers, but they're arranged differently. Now, the ground substance is colorless, clear, viscous, and it fills the spaces between the cells and slows pathogen movement. Remember, we talked about loose connective tissue. That's the packing material of the body. An example of that would be fat or adipose tissue. Dense connective tissue is tough, strong, and durable. And an example of dense connective tissue would be the tendons. This illustration shows you all the cells within the connective tissue proper. You see the macrophage, you see the blood in the vessel, you see the adipocyte, fat cells, you see the ground substance, you see the white blood cell, you see the fibroblast, you see the mast cell, and you see the elastic fibers. This shows you the location and the function of connective tissue proper. This is showing you the location and function of adipose tissue, or the adipocytes. This is showing you the location and function of the reticular tissue in the liver. This is showing you the location and function of the dense regular connective tissue in the tendons. And then this is showing you the dense irregular connective tissue with its location and function in the hypodermis. Now we're going to begin fluid connective tissue. Fluid connective tissue is made up of blood and lymph. They both have a watery matrix of dissolved proteins, but they do carry specific cell types or formed elements. For example, in the blood, we carry red blood cells, white blood cells, and platelets as the formed elements. Now we go on to supportive connective tissue. That includes cartilage and bone. Cartilage is a gel-type ground substance, and it's used for shock absorption and protection. Bone is calcified and it's made rigid by calcium salts and minerals, and it's for weight support. The cartilage matrix includes proteoglycans derived from chondroitin sulfates, and the chondrocytes are the actual living cells, the cartilage cells, and they're surrounded by lacunae. Remember that chondrocytes are avascular, and they're found in pockets called lacunae, so it doesn't have good blood flow. That's why when we have cartilage damage, it's usually a slow and long process of healing. And there's something called perichondrium, which is the outer fibrous layer for strength, and then an intercellular layer for growth and maintenance. There are certain types of cartilage. For example, we have hyaline cartilage. It's stiff and it gives flexible support. It reduces friction between bones. It's found on between the synovial joints, the rib tips, the sternum, and the trachea. There's elastic cartilage, and it's supportive but bends easily. It's found in the external ear and epiglottis. And then there's fibrocartilage, which limits movement and it prevents bone-to-bone contact. This is found in the pads of the knees, between the pubic bones and the intervertebral discs. This is an illustration of hyaline cartilage. This is an illustration of fibrocartilage. Now, in the bones, it's made of a particular tissue called osseous tissue. It's strong, hard calcium compounds, and it resists shattering due to flexible collagen fibers. The cells of the bone, or the bone cells, are called osteocytes, and they're arranged around central canals. They have a hard outer cover, and that's called a periosteum. And underneath that is a fibrous layer and a cellular layer. This is an illustration showing you the actual bone and the actual circular nature. It's cylindrical, and that gives the bones its strength. This is a final table comparing and contrasting cartilage with bone.